an interstellar object whirling through our solar system is actually a nuclear-powered spacecraft sent by aliens to test how humans respond.
Behind NASA's polished press releases, something unexpected slipped out. Images never meant for the public eye. Leaked frames of a strange celestial visitor, now named 3I Atlas, have ignited a storm of questions scientists can't easily dismiss. This is only the third interstellar object ever recorded, yet its images hint at anomalies that don't fit neatly into scientific explanations. Fear, hope, and speculation swirl. Is 3I Atlas just another frozen wanderer, or something far more profound? Stay with me, because these leaks may redefine our place in the universe. The leaked images only deepen the mystery. Strange glints, shadows that defy explanation, and a chemical makeup unlike any comet we've known. Astronomers insist on patience, but the clock is ticking. Is Atlas simply an odd wanderer, or could it be something far more unsettling hidden in plain sight? Let's get into it. The discovery of Atlas and the race to understand it. On the night of July 1, 2025, an Atlas survey telescope picked up something unusual. Atlas, short for Asteroid Terrestrial Impact Last Alert System, is designed to scan the skies for objects that might come too close to Earth. But that night, its cameras caught a faint object moving in a way that didn't match the usual behavior of asteroids or comets. Upon further orbital analysis, something extraordinary was revealed. This object was traveling on a hyperbolic path, meaning it had come from beyond our solar system. It has since been catalogued as Atlas, officially designated C 2025-N1 Atlas. Within hours, astronomers realized they were looking at something extraordinary. This object wasn't from around here, as it wasn't bound to our sun like the countless other icy bodies that drift in the outer edges of the solar system. Instead, it was on a path that screamed of an interstellar origin, cutting across our cosmic backyard before vanishing back into the deep. They gave it the name Atlas, marking it as the third interstellar object ever recorded, after Oumuamua in 2017 and Borisov in 2019. For scientists, moments like this don't come often. These objects are like bottled messages drifting across the sea of space. They are frozen records of what other solar systems might be like. Pieces of alien worlds breaking loose and wandering into ours. Now, another one has arrived, ready to be studied. Telescopes worldwide rushed to lock on to the object. Time was critical, because interstellar visitors move fast and never linger. Early images revealed a faint glow surrounding it, a hazy shell of dust and gas known as a coma. This meant it wasn't just a bare rock like Oumuamua appeared to be, but something more comet-like, shedding material as it warmed in the sun's light. Astronomers were thrilled because this was another interstellar comet. Another rare opportunity to learn. However, as more data arrived, the story grew murkier. What exactly was hiding in those pictures, and why were some astronomers unsettled by what they saw? Once Atlas was confirmed, the countdown began. Astronomers knew they had only a few weeks before it slipped behind the sun and out of reach. So NASA brought out its most powerful tools. The Hubble Space Telescope focused its legendary gaze on the object, while the James Webb Space Telescope followed, using its infrared vision to search for chemical fingerprints hidden in the light. Ground-based observatories joined in, determined to capture every possible detail from the fleeting visitor. The first official images released to the public looked almost underwhelming. It was just a tiny smudge against a black background, with no clear details of a solid body. Even Hubble couldn't resolve a nucleus. All it could do was measure the brightness of the coma and set limits on how big the central core might be. It suggested something small, maybe a few hundred meters wide at most, and this alone was fascinating because it meant such a tiny fragment had managed to drift between the stars for who knows how long before finding us. However, Webb's readings painted a strange picture. Instead of the familiar mix of water vapor and carbon monoxide that astronomers expected from a comet, the spectra showed an unusual spike of carbon dioxide. It was far richer in CO2 than comets born in our own solar system, and this raised new questions. Did it form in a colder, more distant region around its parent star? Or did its journey strip away lighter materials and leave this odd chemical profile behind? For scientists, these mysteries are thrilling, but for the wider public, the official releases were slow, careful, and technical. This is when the so-called leaks began circulating online. Images appeared on forums and social feeds, supposedly pulled from inside NASA's data vaults. They claimed to show strange structures, shadows, even metallic glints in the coma. And because they looked sharper and more dramatic than the grainy smudges NASA had shared, people began to pay attention. Astronomers, on the other hand, grew frustrated because they knew how easily space images could be manipulated. A stretched exposure here, a contrast adjustment there, and suddenly a background star looks like an artificial shape. But some of these leaked frames weren't just harmless curiosities. They began sparking headlines suggesting NASA was hiding the truth. This tension only deepened when a few respected scientists spoke out of turn. One of them was Avi Loeb from Harvard, who had already stirred controversy by suggesting Oumuamua might have been artificial. He hinted that Atlas could also be worth considering in that light. While most astronomers rolled their eyes and doubled down on the natural explanation, the public heard something else. So, are these images revealing something profound, or are we chasing shadows in the noise? The answer depends on who you listen to, and the divide is only growing. Tracking Atlas and decoding its images. In astronomy, every discovery comes with a deadline because objects move, observation windows close, and when the subject is an interstellar visitor like Atlas, the clock runs faster than ever. From the moment the Atlas Survey Telescope in Rio Hurtado, Chile, spotted the moving speck on July 1, 2025, observatories worldwide scrambled to track it. The first nights were a frenzy, with teams in Chile, Spain, and South Africa piecing together glimpses to refine its path. Yet, despite all this effort, the images stayed stubbornly unclear. Hubble revealed only a faint, shapeless glow, while Webb's spectra hinted at a strange chemical mix, but offered no clear picture of its structure. Meanwhile, observers noticed something odd. The coma wasn't symmetrical. A faint brightness seemed to lead the supposed nucleus. So was it just dust playing tricks with sunlight? Or was something else at work? Behind the scenes, astronomers knew the real challenge wasn't just gathering data, it was beating the clock. By late summer, the comet would slip into the sun's glare, becoming impossible to observe. So missing that window could mean waiting decades, maybe centuries, for another interstellar visitor to appear. This sense of urgency shaped every decision, and the more telescopes pointed its way, the better the chances of unlocking the secrets of this fleeting cosmic gift. For every careful measurement scientists reported, the online chatter only grew louder. Grainy, leaked images spread faster than official results, and many people didn't realize how much processing goes into a scientific photo. Long exposures, background subtraction, false color enhancements. Each step can create illusions. If you don't know what you're seeing, and illusions were exactly what fueled the speculation. For researchers, it became a battle on two fronts, racing to collect solid data before the object vanished, while also trying to keep the public from running away with the wrong story. The truth, though, was hidden in plain sight. The official images carried secrets of their own, but only if you knew how to look. The next round of observations didn't deliver dramatic images, but they did bring valuable detail. NASA's SPHEREx mission, short for Spectrophotometer for the History of the Universe, Epoch of Reionization, and ICES Explorer, is a small space telescope that scans the entire sky in the near-infrared from about 0.75 to 5 micrometers, recording low-resolution spectra across roughly 100 bands. Along with Webb, it turned its sensitive instruments on ATLAS and returned a clearer chemical profile. Both observatories detected a strong carbon dioxide signal with only faint traces of water. This result surprised researchers, since comets in our own solar system usually contain abundant water ice. This visitor, by contrast, appeared unusually rich in carbon dioxide, hinting at a formation history unlike anything we've seen before. Teams also went back through older survey images and found the object hiding in plain sight. Pre-covery frames from wide-field surveys, including data from TESS, suggest faint activity months before the discovery date. If that is right, ATLAS began reacting to sunlight far from the inner system, possibly near the distance of Jupiter or beyond. Early activity that far out helps explain why the coma looks the way it does now. It means volatile ices were already lifting dust and gas long before the comet slid into view. While Hubble's high-resolution imaging didn't reveal a clean, solid core, it did give useful limits. Based on how bright the coma is and how the light scatters, astronomers estimate the solid nucleus is probably not huge. Some calculations put an upper bound of a few kilometers across, while other models that account for a bright coma prefer a much smaller size, perhaps only a few hundred meters. In short, the solid heart is likely on the small side, and most of what we see through telescopes is just dust and gas in the surrounding shroud. This makes simple size claims risky, because a bustling coma can make a tiny nucleus look far bigger than it really is. There are other oddities too, because some teams measuring the object's motion have reported tiny deviations from the path gravity alone would predict. Those non-gravitational accelerations can show up when jets of gas push the body, and they are common in active comets. So far, most researchers favor that natural explanation: uneven outgassing driving slight changes in trajectory. A few analysts have explored other possibilities, such as large dust grains or fragments contributing to the observed behavior. But those ideas remain speculative and are under careful study. What all this adds up to is a picture that is stranger than a typical comet, but not beyond the reach of normal science. ATLAS appears to be a small, fragile body, active at large distances and unusually rich in carbon dioxide. Its odd chemical fingerprint and quirky motion are interesting because they reveal just how diverse objects from other star systems can be. They do not, at this stage, amount to proof of anything exotic. Instead, they are clues that push astronomers to refine models of how comets form and evolve in environments different from our own. This does not stop the internet from filling the gaps with bolder stories, but when you strip away the hype and look at the measurements, you see a more careful tale, an uncommon visitor that challenges some assumptions but still fits within the kinds of natural processes scientists know how to test. The data are far from complete, and the debates are alive. More spectra, more images, and more modeling will be needed to sharpen the picture. If the images were raising eyebrows, the reactions from astronomers themselves would push the debate even further, drawing a line between skepticism and wonder. Expert debate, and what the measurements actually show. When it comes to discoveries like this, science usually moves as one slow, careful machine. Data is gathered, papers are written, peer review smooths out mistakes, and only then do conclusions settle in. But with ATLAS, The voices didn't all sing in harmony. Mainstream astronomers looked at the object and saw a comet. An unusual one, yes, but still a comet. They pointed to the coma, the odd but explainable chemical makeup, and the faint asymmetry that could easily come from outgassing jets. For them, the story wasn't that mysterious. It was simply a natural body carrying the signature of another star system, no different in principle than Borisov, which had passed through just a few years earlier. On the other side were the outliers. Avi Loeb, a Harvard astronomer already known for suggesting that Oumuamua might have been artificial, spoke up again. He argued that the unusual CO2 signature and the odd brightness in front of the object were reasons not to dismiss non-natural possibilities too quickly. His words carried weight, not because most scientists agreed with him. They didn't, but because he had a knack for capturing headlines. When Loeb talks, people listen. The split wasn't really between scientists and the public, it was between different ways of handling uncertainty. Most astronomers prefer to wait for strong evidence before making bold claims. They don't want to risk their reputations by jumping too soon. However, others, like Loeb, argue that bold speculation keeps the conversation alive and pushes the field to consider ideas that might otherwise be ignored. The public, caught in the middle, often missed the nuance. When one scientist said comet and another suggested it may be artificial, it didn't sound like healthy debate. Instead, it sounded like a conspiracy. Was NASA hiding something? Were scientists split because the truth was too big to admit? In reality, the difference lay in tone and caution, not in the data. The evidence was still the same. Blurry images, puzzling spectra, a faint, lopsided coma. The challenge was that humans are natural storytellers. We see a smudge in the sky and want it to mean something. For some, it became an alien probe drifting silently through our system. For others, a natural messenger carrying the chemistry of another world. For everyone, it meant mystery. And mystery has a way of filling the silence with whatever people most want to believe. But what did the numbers actually say? When scientists stripped away the speculation and dug into the raw measurements, the picture they uncovered was both stranger and simpler than the rumors suggested. The first thing to understand is how astronomers actually study an object like Atlas. When you hear about an image from Hubble or Webb, it's not like pointing an iPhone at the night sky. These telescopes capture light that is then processed, layered, and analyzed with mathematics. Every smudge, every faint pixel matters. Take the brightness profile of the coma. For most comets, the glow is brightest near the center, where the nucleus is, and then it fades outward in a fairly smooth way. With Atlas, though, the drop-off wasn't perfectly smooth. It looked like the coma was thicker in some directions, almost as if material was streaming unevenly. This suggested either strong jets of gas breaking free or a nucleus that wasn't shedding dust evenly. In simpler terms, the comet didn't look balanced. There was also the chemistry. Webb's infrared spectrographs act like a prism, splitting light into a rainbow that reveals hidden fingerprints. Each chemical molecule absorbs light at certain wavelengths, leaving little dips in the spectrum. When scientists looked at Atlas, the fingerprints were clear. A strong presence of carbon dioxide, more than expected, and surprisingly little water. In our solar system, comets usually form with plenty of frozen water, especially if they come from the outer regions. So why was this visitor so different? One idea is that it formed much farther out from its parent star, in a region where water ice was scarce, but carbon dioxide ice could remain stable. Another is that it lost much of its water during its long journey through interstellar space, baked away by cosmic rays and the slow heating of starlight. Either way, the chemistry told astronomers one thing for sure. Other solar systems don't necessarily build comets the way ours does. And then there was the size. Hubble couldn't see the nucleus directly, but it could place an upper limit. Based on the faintness of the coma and how it scattered light, astronomers guessed the solid body inside couldn't be bigger than a few hundred meters across, maybe smaller. That made it a pebble by cosmic standards, yet one that had traveled light years to reach us. To put it simply, the data painted a picture of a small, fragile body that was strangely rich in carbon dioxide and shedding material unevenly. There were no clean metallic reflections, no geometric shapes, nothing that screamed artificial, but there were also no simple answers. This comet was different, and the difference is what drives science forward. Still, the gaps in the story gave rise to speculation. Why did the coma look so odd? Why did the spectra differ from anything we'd seen before? Why did leaked images seem to show things the official ones didn't? Each question was a doorway, and some people couldn't resist stepping through to more exotic explanations. Astronomers, on the other hand, were very careful. They knew that extraordinary claims require extraordinary evidence, and so far, the evidence pointed to something natural, even if unusual. But that didn't stop imaginations from running wild. If science suggested one story and the rumors told another, what did it all mean for us? The implications reached far beyond just one comet. They touched on how we see our place in the universe, the scientific payoff, and the leak problem. When we step back from the technical talk, it's easy to forget the bigger picture. This isn't just about one comet. This is about a fragment of another star system drifting into ours. Imagine standing on a beach, picking up an ordinary-looking stone, and then realizing it had somehow washed in from a continent you've never seen. This is what astronomers are holding here. Evidence from a place humanity may never reach. A clue from another solar nursery scattered across the galaxy. If Atlas is natural, its implications are profound. The unusual mix of carbon dioxide and surprisingly low water content hint at conditions very different from the disk of gas and dust that gave rise to our own planets. The single chemical fingerprint suggests that the building blocks of worlds elsewhere may be forged under rules unfamiliar to us. The recipes we've drafted from studying comets in our solar system may not apply across the galaxy. Just like that, an icy traveler challenges decades of assumptions, and then comes the deeper question, the one that always lingers at the edge of discovery. What does this mean for life? Every comet is more than ice and rock. It is a frozen time capsule, preserving the conditions of its birth. On Earth, scientists suspect that billions of years ago, comets may have delivered water and organic molecules, the seeds that helped biology ignite. If comets in other star systems are this chemically diverse, then the stage for life across the galaxy may be wider, stranger, and more varied than we've dared imagine. A CO2-rich comet doesn't prove life exists elsewhere, but it broadens the possibilities. It reminds us that the galaxy is running countless experiments at once, across billions of years. Each interstellar comet whispers that our version of chemistry, our version of biology, may be only one of many. But the implications aren't only philosophical, there are practical stakes too. Every interstellar object is a reminder that our solar system is not an isolated bubble. Space is a thoroughfare, a highway of wanderers. Things from out there do come in here, so while Atlas poses no danger, its trajectory never comes near Earth. The fact remains, we've now seen 3 interstellar visitors in less than a decade, and this raises unsettling questions. Are these encounters more common than we ever realized? And if so, how many slipped by unnoticed before our telescopes were sharp enough to catch them? Some researchers argue that as our sky surveys improve, interstellar visitors will become regular discoveries. This means more opportunities to learn, but it also means we have to be ready. A larger interstellar object on a closer trajectory could pose consequences we're unprepared for. It is not fear-mongering. It's planetary defense. The same field that scans for asteroids now has to consider the possibility of foreign bodies entering our neighborhood at interstellar speeds. So whether you care about the chemistry, the philosophical stakes, or the practical reminder that Earth sits on a cosmic crossroads, the truth is clear. Atlas matters. It's not just another comet. It's a messenger. If it's such a gift to science, why has the public heard so much through leaks and whispers instead of straight answers? This part of the story reveals as much about us as it does about the comet. The word leak carries weight because it conjures secrets, hidden truths, cover-ups. So when early images of Atlas appeared online before NASA had released its official results, the reaction was predictable. People assumed something was being kept from them. Meanwhile, here is the reality. Astronomy doesn't usually thrive in the shadows. Observations are logged, shared, and often stored in open databases that any researcher can access. The reason official images take time isn't that NASA is hiding anything. It's that the data must be cleaned, calibrated, and checked. Raw images can be deeply misleading. Cosmic rays leave streaks across frames and background stars intrude. Electronic noise paints speckles that don't belong. To the trained eye, those flaws are routine, but to the untrained, they can look like anomalies, or worse, like proof of something extraordinary. The leaked images looked sharper and more dramatic than official releases precisely because they weren't presented with caution. Contrast was pushed, colors were exaggerated, and specks stood out like glowing structures. To someone scrolling late at night, it was easy to believe these were glimpses of alien machinery. But to astronomers, they were simply flawed frames dressed up with artificial clarity. This is where science's patience collides with the internet's speed. Scientists take months to analyze spectra, and months more to draft peer-reviewed papers. The internet takes seconds to spread a rumor, and in that gap, speculation thrives. A blurred pixel becomes an alien probe. A forward-scattered coma becomes the glow of an engine. A cautious, "we don't know yet," becomes NASA is hiding the truth. The frustration is real on both sides because the public wants to be part of discovery. They don't want to wait a year for a technical paper locked behind paywalls and jargon. They want to share the journey in real time. They want to look over the scientists' shoulders, and maybe that's the heart of the leak dilemma. Transparency versus trust. If agencies release raw data instantly, the risk of misinterpretation soars. If they hold back until everything is polished, suspicion grows. This tension isn't new. It erupted with Oumuamua, the same with Borisov, and now it's repeating with Atlas. The difference is that with each new interstellar object, the stakes feel higher. We know how rare these encounters are. Every one of them feels historic. So what's the solution? It may lie not just in better telescopes, but in better communication. Scientists are realizing that it's not enough to gather the data. They must tell the story too. Not with hype or secrecy, but with a clarity that preserves the wonder without opening the door to distortion. Because, at the end of the day, this isn't about hiding or revealing, it's about trust, and trust, once lost, is hard to win back. Which brings us to the closing question. With all the mystery, the leaks, and the debates, what should we truly take away from this strange visitor? The answer may be quieter and more powerful than the headlines suggest. Beyond the headlines, Atlas as a messenger from the cosmos. Every discovery tells a story, but not every story is easy to hear. Atlas is more than a dot on a screen or a trail of frozen gas. It is proof that the universe still has the power to surprise us. We live in an age where information moves faster than understanding, where noise often drowns out truth, but behind the speculation and the leaks lies something profound. A reminder that our solar system is not alone, Think about it. For most of human history, the stars were fixed and eternal, an unchanging canopy. Then telescopes revealed planets, galaxies, and expansion itself. Now, in our own lifetime, we've watched visitors from alien systems sweep through our skies. They don't stay long, but their presence leaves an imprint. They remind us that the cosmos is not a static backdrop. It is alive, dynamic, filled with wanderers whose stories we're only just beginning to read. For astronomers, Atlas isn't about proving aliens or suppressing rumors. It's about mapping possibilities. Each interstellar visitor is a data point, a clue, a test of our theories about how stars and planets form. Each one offers a glimpse into the diversity beyond our neighborhood, and each one carries the same message. We are part of something much bigger. The real urgency among scientists isn't that this comet hides some extraordinary secret. It's that these opportunities vanish quickly. By the time our best instruments lock onto them, they're already fading back into the dark, so studying them is like trying to understand a stranger's life from a single snapshot. This is why every fragment of data matters. Every spectrum, every image, every observation counts because, once it's gone, that exact messenger will never return. For the rest of us, the meaning is just as important. We're not bystanders. We're participants in a story that stretches across light years. The very fact that we can detect an object like Atlas proves how far human science has come. The fact that we debate what it means proves how deeply we care, and the fact that it still leaves us with questions proves that wonder is alive. So, what's the lesson here? It's not that NASA is hiding something, nor is it that aliens are guiding comets through our skies. The lesson is simpler and far more powerful. The universe is richer, stranger, and more surprising than we imagine. And in that strangeness, there is hope. Hope that discovery never ends. Hope that mystery remains. Hope that no matter how much we think we know, there will always be more waiting. As Atlas drifts back into the shadows, it leaves us with a choice. We can choose to dismiss it as another fleeting headline, another curiosity in the news cycle, or we can recognize it for what it truly is, a messenger from beyond, a reminder that the story of the universe is unfinished. So here's the question: when the next visitor comes, and it will we be ready to listen, or will we be too busy chasing leaks to hear what the cosmos is trying to tell us? Let us know your thoughts in the comments, and don't forget to like, subscribe, and share. If you enjoyed this video, click on the next video on your screen.